Yes, by taking -1 common from first row, second row, and third row, we have got delta is equal to minus delta. So delta is equal to minus delta. If you bring minus delta onto this side, so delta plus delta, 2 delta is equal to 0 I get. So if 2 delta is equal to 0, delta is equal to 0 by 2, that is 0. So we have to prove that the given determinant is equal to 0. We have taken this given determinant as delta, and we have got delta is equal to minus delta. So 2 delta is equal to 0. So delta is equal to 0. So that we have done in the last class. We go to the next question. Prove that this is very interesting and it's very important for exam. Prove that determinant of, look at the left hand side, and the answer has to be 4a square b square c square. I'll write the left hand side. I'll write the left hand side. Please observe. Just wait. Just wait. Okay. So I will take the left hand side, LHS. So left hand side, you have to write the determinant. So what is the determinant? Determinant of minus a square, AB, AC. Then what is the second row? BA. BA means AB. Then minus B square. Then BC. Then CA, CB minus C square. This is the left hand side. So I have to get 4a square b square c square without expanding. That is the main question. Without expanding, you have to show that the value of this determinant is equal to 4a square b square c square. So can you tell me the first step? What can be the first step? Can you tell the first step? Can you tell the first step? Yes. What is to be taken common? I will take a common from first row. You can observe a. I will take a common. If I take a common from the first row, what I get? Can you write on the chat box? If I take a common from the first row, what I get? Minus a. I'll get minus a, not a, minus a, then b, then c. So yesterday we have done one property. Whenever you want to multiply or you want to take common, it has to be applied only on one row, not all the elements. If you want to take a common, only from first row, only from second row, not all the three rows. I have taken a common from first row. Similarly, what is common from the second row? What is common from the second row? B is common from the second row. So if I take B common, if I take B common from the second row, if I take B common from the second row, so what I get if I take B common here? B, here also B, and here also B. So I get A, then minus B, then here we get C. If I take A common, I get B minus B, then C. In the last row, third row, similarly, if I take C common, you can see here C, C, C. If I take C common, I get A, then B, then minus C. So by taking C common, I get A, B, and minus C. So what I got outside the determinant is A, B, C. So now what will be the next step? So many of you are thinking plus, minus, plus. By taking the sign scheme, we can expand. But remember, the question is without expanding. When it is without expanding, you have to apply only the properties. You cannot expand it by taking the first row. So what will be the next step? I should get 4a square b square c square without expanding, without taking minors, cofactors. Without doing that, I should get 4a square b square c square. Okay, next step, what I do is I will do one operation here. This is very important. Okay, take out common from. Yes, very good. That's the right thing. Very good, very good, very good. Again, in the first column, you can observe in the first column, what is common? Again, A is common. If I take A common from the column, not row. In the previous step, we have taken A common from first row. Now A is common in the first column. Yes, I have highlighted it. So if I take A common, I get -1, 1, 1. And similarly, take B common in the second column. If I take B common in the second column, I get 1, -1, and 1. 1, -1, 1. And last, C. In the last column, in the third column, if I take C common, I get 1, 1, -1. So like this. So I've taken A, B, C common from first column, second column, and third column. So A, B, C into A, B, C. I get A square, B square, C square. A square, B square, C square. So what will be the next step? Without expanding, please take a notebook and pen and have some privacy. There should not be any disturbance. Then only you can understand these problems. So the next step is I will do one operation here. Yes, find the determinant. No, if you find the determinant plus minus plus, that means you are expanding. You are expanding. The question is without expanding. You cannot find the value of the determinant like that. No, you cannot expand. The question is without expanding. Yesterday, without expanding, we have proved that the value of the determinant is 0. How? By reducing the determinant such that two rows are identical. It was 0. Now it is not 0. But now also you should not expand. So I will do one operation here. What I do is just observe. I will do like this. Yes, anybody can answer? Anybody can answer this question? It's very simple. R2 plus R1. Okay, if yes, let us see. R2 changes to R2 plus R1. If I do R1 changes to R1 plus R2, that also you can do. But I will do R2 changes to R2 plus R1. Second row, first row, I will add. If I add second row and first row, but which row I am changing? I am changing the second row, not the first row. So first, second row plus first row, 1 minus 1, it will be 0. Then -1 plus 1, that will be also 0. That will be also 0. Then 1 plus 1, that will be 2. R2 changes to R2 plus R1. Now, similarly, one more operation. R3 changes to. I have told you in one step you can do two operations, not three. You can change only two rows, either R1 and R2 or R2 and R3 or R1 and R3. You can change R1 changes to R1 plus R2. We can do other both. So I will next write R3 changes to R3 plus R1. We should not write R3 plus R2 because R2 has already changed. So that we should not use. So R3 changes to R3 plus R1. In both the cases, I am using R1. Same row you have to use in both the steps. Usually, 99% of the cases, in these two operations, you have to use the same row. I have used first row to change second row and third row. First row na use madina ಎರಡು ಕಡೆ. So here I am changing R2 and here I am changing R3. So R3 changes to R3 plus R1. Again 1 minus 1 will be 0. Then 1 plus 1, that will be 2. Then -1 plus 1, 0. Next, you cannot write R1 changes to R1 plus R2. That you cannot write. Only two operations I said. So first row I will write as it is. First row as it is. So now what I do is I'll continue here. I'll continue here. So That will be a square b square c square. I have got a square b square c square. This is determinant. Yes. Now, what I'm going to do is I will interchange R2 and R3. R2 interchanged with R3. You know, this is, I think, second property. When you interchange positions of two rows, the determinant value changes only in sign. So when you interchange R2 and R3, the determinant value changes in sign. So it becomes minus. So return -1. So which rows I am changing? R2 and R3. R2 becomes R3, R3 becomes R2. So what is R2 here? 0, 0, 2. That 0, 0, 0, 0, 0, 2, I will bring it to the third row position, 0, 0, 2. And next, what I do? So next, R3 will become R2. R2 and R3 I am interchanging. So second row I have converted to third row. Now third row becomes second row. So what is the third row here in the last step? 0, 2, 0. 0, 2, 0. Yes, you can observe. Second and third row I have interchanged. First row I have done nothing. So when you interchange any two rows, any two columns, according to property 2, you can refer the determinant changes only in sign. So it becomes -1 into that. So minus a square, b square, c square. Now first row as it is, -1, 1, 1. Yes. Now there is one more property. What is that? If all the elements below the diagonal or above the diagonal are 0. I have told you one more property. If all the elements below the diagonal or above the diagonal are 0, then the value of the determinant is product of all the diagonal elements. So you can observe here these elements below the diagonal. So this is the diagonal, principal diagonal. Below that all are 0. Above the diagonal may be also 0 sometimes. Anyone, either below or above the diagonal. So if these three numbers are 0, it's called as upper triangular matrix. Determinant of upper triangular matrix or triangular matrix. Determinant of a triangular matrix, whether the elements below the diagonal or above the diagonal. If they are 0, then it's called as a triangular matrix. For determinant of triangular matrix, the value is just multiply these three numbers. -1, 2 into 2. What is -1 into 2 into 2? 2 into 2 is 4. -1 into 4 is -4. So I get minus into minus plus 4a square b square c square. So this is RHS. See, without expanding I have done. I have not expanded. Expanding means by taking plus minus plus, taking that first row. So that is called as expanding. Without expanding I have done. So whenever the question is without expanding, you have to use the properties. If two rows become identical, it becomes 0. Now here two rows are not identical. The elements below the principal diagonal are 0. Sometimes above the diagonal may be also 0. It's called as triangular matrix or determinant of triangular matrix. You can call triangular determinant. For a triangular determinant, just you have to multiply these three numbers. Diagonal elements, you will get the value of the determinant directly. You need not expand. So that is the answer. 4a square b square c square. Is it clear? It's very simple. You have to concentrate. First, I have taken A, B, C common from first, second, third row. Then again, I have taken A, B, C common from first, second, third column. Then I have operated these two operations. R2 changes to R2 plus R1. R3 changes to R3 plus R1. So these are the important steps here. I am changing R3 and R2 by using R1. So after changing R3 and R2, R1 remains as it is. And once again, in the last step, R2 and R3 are interchanged. Why I'm interchanging? Because here, if you observe, these three elements are 0 here. These are not the elements below the diagonal. They are not in that position below the diagonal. This 0 is along the diagonal. So to bring it below the diagonal, I have interchanged R2 and R3. So by interchanging R2 and R3, these zeros will come here. Actually, zeros are here. This 0 is along the diagonal actually. So I want to change it. The 0 should not be there in the diagonal. So by interchanging R2 and R3, R2 and R3, you can observe the diagonal elements are not 0. -1, 2, 2. These are non-zero. And zeros have come here. So to bring zeros to the position of that below principal diagonal. I've interchanged R2 and R3. So at last, by taking the product of these principal diagonal elements, the value of the matrix, the value of the determinant will be -4. So minus into minus is plus. Yes. Any doubt? Yes. If there is any doubt, you can ask. No doubts. Okay. We go to the next question. Next problem. Yes. So next question. These are important questions, and please listen to me carefully. These questions carry. Yes, I've taken -1 not common in the fourth step. I've not taken -1 common. -1 automatically it will come according to the property. Which property? Whenever you interchange R2 and R3, R1 and R2, C1 and C2, whenever you interchange, that -1 will come outside the determinant. -1 is not there in the determinant. I'm not taken common. Like when you interchange the rows or columns, the determinant value changes in sign. So that's why I've written -1. It changes only in sign, not in magnitude. So whenever you interchange rows, any two rows or any two columns, you write -1. So that's a property. It's not a common factor. Okay. Question number 6. The main question is, heading is, by using the properties of determinants. You have to apply the properties once again, but without expanding. This is not given. Without expanding anta helilla means you can expand, but you should not expand in the first step, because please listen to me very carefully. It's an important question for 4 marks in the board exam. It will come in part E. So using the properties we have to do, but you can expand, because question is not like without expanding you have to do it. It's not given like that. So you have to apply the properties as much as possible till the end. Till the end means when you get some zeros, 0, 0. So you have to get more number of zeros. That is a technique here. You have to get more number of zeros, then expand it, and your answer should be A minus B into B minus C into C minus A. So if you expand in the initial step itself, in the first step, plus minus plus, if you expand, what happens? You will get first 1 plus 1, leave this row and column. I get BC square, CB square. But where is the answer? BC square, CB square is not there. Answer is A minus B, B minus C, C minus A. That is the answer. So by expanding this, you will not get these brackets. Brackets varange illa. You get BC square, CB square, AB square. So we should not expand in the first step. First, you have to apply the properties. First, you have to get these factors. What are the factors here? A minus B you have to get. B minus C you have to get. C minus A you have to get. After getting this answer, in the last step, you have to expand. Last step means you have to get some zeros. After getting zeros, you have to expand. Okay, how to get first factor here? First factor is something like A minus B. So sometimes you'll ask, how should we come to know that R1 changes to R1 minus R2? How we have to apply that property? Idanne apply ಮಾಡಬೇಕಂತ ಹೆಂಗ್ ಗೊತ್ತಾಗ್ತದೆ ನಮಗೆ ಅಂತ ನೀವು ಕೇಳ್ತೀರಿ. So ಅವಾಗ ನಾವಿಲ್ಲಿ right hand side ನೋಡಬೇಕು. By looking at the right hand side, you'll come to know which operation we have to do. Okay, you have to look at the answer right hand side. So what is the answer here? Right hand side, the first factor is A minus B. Now let us come to the solution. So how to get this A minus B? Can you tell me how to get A minus B? So A is here and B is here. How to get A minus B? A is present in first row. No, see, somebody has written R2 minus R1. If you do R2 minus R1, R2 means B, R1 means A. So R2 minus R1 means B minus A. That is wrong. I want A minus B. So if you do R2 minus R1, so R2 means second row. Second row means B is present here. We get B minus A. But I want A minus B. So A is present in first row. This is first row. This is second row. This is third row. Yes, A minus B. To get that, you write R1 changes to R1 minus R2. Right. Now tell me what I get. R1 minus R2. So what I get? R1 by doing R1 minus R2. First number is 1. This is R1. R1 means there are 3 elements. R2 means there are also 3 elements. So 1 minus 1. 1 minus 1 is 0. 1 minus 1 is 0. And what is next? A minus B. This is A minus B. And next what? A square minus B square. This is A square. This is B square. So I get A square minus B square. But what are the factors of A square minus B square? A plus B. A plus B into A minus B. A plus B into A minus B. This is the first row. By doing R1 changes to R1 minus R2, I get 1 minus 1, 0. Then A minus B, A square minus B square. A square minus B square means A plus B into A minus B. But also I have to get B minus C also in the answer. The right hand side also contains B minus C. How to get B minus C? This is B and this is C. How to get? Yes, not R1 minus R3. B minus C means R2 minus R3. If you write, see, already you have changed R1. After changing R1, again R1 you cannot write. R1 minus R3, that is wrong. Once you change R1, it is over. Next you have to change R2 or R3, only 2 options. Again you cannot write R1. Okay. Now R2 changes to R2 changes to R2 minus R3. R2 minus R3. So what I get? R2 minus R3. This is 1. This is also 1. So I get 1 minus 1, 0. Next I get B minus C. B minus C. Next I get B square minus C square. B square minus C square means B plus C into B minus C. Correct? And again R3 changes to, that is wrong. Only 2 operations I have told. So that is the main thing here. Only 2. You have changed R1, you have changed R2. You cannot change R3. You don't have any option like that. Third row as it is, 1 C C square, like this. Is it clear? So why I'm doing R1 minus R2? Because I want to get A minus B in the answer. Why I'm doing R2 minus R3? Because R2 contains B, R3 contains C. I want B minus C in the answer. I want B minus C in the answer. So that's why I'm doing R2 minus R3. So I got B minus C. So what is common in the next step? What is common in the next row? I'm sorry, in the next step, what I have to write? Which factors are common here? Not C is not common. C square and C is common, but here is 1. 1 is there, so you cannot take C common. In the first row, tell me in the first row what I get. In the first row, I will take A minus B common. A minus B common. If I take A minus B common in the first row, I get to 0. 0 means 0 only. When I take A minus B outside, so what happens to this A minus B? Already I have taken it as a common factor, so I get 1. A minus B ನಾನು ಹೊರಗಡೆ ತಗೊಂಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. So 1 ಬರ್ತದೆ ಇಲ್ಲಿ. ಇಲ್ಲಿ A minus B ನಾವು ಇಲ್ಲಿ ಹೊರಗಡೆ ತಗೊಂಡ್ಬಿಟ್ರೆ, ಕಾಮನ್ ತಗೊಂಡ್ಬಿಟ್ರೆ ಏನಿಲ್ಲಿ ಬರ್ತಾ ಹೇಳ್ತೀನಿ. What I get here? I get A plus B. A plus B. Correct? So I have taken A minus B common. See, common factors you have to take only in one row, not in all the rows. Only one factor in one row. A minus B in one row, in the first row. Now in the second row, what is common? In the second row, I am having B minus C common. If I take B minus C common, if I take B minus C common, if I take B minus C common, in the second row, what I get? I get 0, 1, and B plus C. B plus C. Third row, nothing is common. 1 C C square, like this. So this I get. So 10 more minutes are there. Let us finish this problem. Okay. Yes. So I get A minus B into B minus C. So after that, what I get? What I get after that? So A minus B into B minus C. I will do it here. A minus B into B minus C is there. So what will be the next operation? What will be the next operation? Shall I expand by taking the third row? Somebody is suggesting. Yes, you can expand. If you expand, no harm is there. Where there is zeros, more number of zeros. Where are more number of zeros I'm having? You have to expand by taking that. You can observe zeros are there in the, yes, in the first column. Where is the first column? Yes, here. Yes. You have to expand by taking the first column. You can expand by taking the first row also, but I'm not suggesting that. Why? Can you tell me why we should not expand by taking first row? First row you are having, what are the elements in the first row? 0, 1, A plus B. A plus B means it's a big term. But here 0, 0, 1, very easy. There are two zeros and last number is 1. But here in the first row only 0, 1, A plus B. Listen to me. In the first row only one zero is there. Next A plus B is there. You have to multiply and all those things. But in the first column, I have highlighted it. Yes. Round madi nodri. 0, 0, 1. Very easy. 0, 0 are there. Only 1 is there. So you have to expand by taking that row or column which contains two zeros. If there are no two zeros, you can expand by taking any row or column. But in that row or in that column, the terms must be small. 0, 1, A, C. You should not have A plus B, A square like that. It should not be complicated. So 0, 0, 1. First column. What is the sign scheme? Sign scheme, this is plus. After plus, this will be minus. After minus, this will be plus. Plus, minus, plus is the sign scheme. So expand by taking the first column. New amele first row ತಗೊಂಡು expand ಮಾಡಿ ನೋಡಬಹುದು. You get the same answer. But I will take that row, that column which contains more number of zeros. The terms are very small. So by taking the first column, I'll expand it, and what I get, I will show you. Now here, yes, just wait. Okay, so if I expand by taking the first row, what I get? I'm sorry. Yes, what I get? So I'll expand. I'll put a bracket. I'll expand it. So already I got A minus B here. A minus B into B minus C. Now I will expand it. For expanding, you can put a bracket or anything. Now I'm expanding by taking what? I'm expanding by taking the first column. So what is the first number in the C1? Column 1? 0. 0 into anything is 0. Next, what is the next number? I'm expanding by taking first column. Look at the column. I have highlighted. Highlight ಮಾಡಿ ನೋಡ್ರಿ. 0. Next second term is also minus 0 into anything is 0. 0 into anything is 0. What is the last number? 1. Last number is 1. So 1 into another bracket. How you expand? You have to leave that row and leave that column. So when you leave that row and column, what I get? So when you leave that row and column, I get this one. If you delete this row and this column, you know how to expand. So 1, it is there in first column and in third row. If you delete this row and column, we get these 4 numbers. This is called as minor. What are the numbers here? 1 A plus B, 1 B plus C. How you expand it? Can you tell me? 1 into B plus C. 1 into B plus C is B plus C. Then minus into bracket. Minus into bracket. What is 1 into A plus B? 1 into A plus B is A plus B. Are you getting my point? 0, 0. You have to write as it is. 0 into anything is 0. Last 1 into, leave this row. Delete this row. Delete this column. You get 1 into B plus C minus of 1 into A plus B. Expansion. How you expand second order determinant? Cross multiply and subtract. So 1 into B plus C, then 1 into A plus B. So B plus C minus into bracket A plus B means minus A minus B. Both of them become minus A minus B. So I get B plus C then minus A minus B. Because minus into plus is minus, correct? So which will be cancelled here? Plus B minus B will be cancelled. So what I get? Next step. Already I got two factors here. A minus B, B minus C, A minus B, B minus C. And what I get after simplifying this? What I get? So the next bracket will be next bracket, that is yes, 1 into 1 into what? So minus B plus B will be cancelled. So here I am having C and here is minus A. So C minus A. C minus A. C minus A. Yes, so this is the RHS. Okay, not understood. Which step? Which step? I'll explain once again. So I've taken left hand side. R1 changes to R1 minus R2. Is it clear? Why we have to do R1 minus R2? You may ask. Because I want A minus B in the answer. See, my answer to your question like why we should do it is RHS. I focus on RHS. RHS, there are three factors: A minus B, B minus C, and C minus A. How to get A minus B? I should get A minus B. Where is A? Observe the determinant. Determinant and nodary. A is nodary. A is present in first row. I hope you can observe. A is present in first row. And where is the yes? Yes. Where is B? A is present here. A is present in first row. Where is B? B is present in second row. So when A is present in first row and B is present in second row, how to get A minus B? You have to subtract this minus this. So R1 minus R2. That is the first step. R1 minus R2. Then to get B minus C, B is the notary. B is here, second row. C is in third row. So B minus C means second row minus third row. So I'll get B minus C. Then you take common. What is common in the first row? The next step you can observe A minus B, and here also A minus B. 0 means it contains every factor. So by taking A minus B common, 0, 1, A plus B. I get 0, 1, A plus B. In the second row, what is common? In the second row, B minus C is common. By taking B minus C common, I get 0, 1, B plus C. Third row as it is, we cannot change. Then after that, you have to expand. How to expand? By taking the first column. What is the first column? 0, 0, 1. Why I am selecting first column? Because there are two zeros and numbers are very easy. One is there. In the first row, why I am not taking first row and finding the value of the determinant? Because first row only 1 0 is there, and 0, 1, A plus B. A plus B means it's a big number, very big expression. So by expanding, you'll get so many terms. You'll be confused. So always choose small numbers, 0, 0, 1, like that. So by taking that, I'll expand plus minus plus, 0 into anything 0, 0 into anything is 0. I return 0, 0, and last is 1 plus 1 plus 1 into. So how to expand and how to find the value of the determinant? You know, you have to delete the row and column. Finding the value of the determinant means we call it as expansion. Expanding means you have to find the value of the determinant. Both are same. So how to find the value of the determinant? You have to cross multiply and subtract. I have done. So if you cross multiply 1 into B plus C, I have written B plus C. Then minus 1 into C plus B. Minus into C plus B means minus into plus will be minus. So both will become minus. Minus C minus B. So plus B minus B will be cancelled. This is A. So plus B minus B will be cancelled, and I get